Hello my dear students, welcome to one more amazing session from Infinity Learn by Sri Chaitanya Academy. This is Suresh, Faculty of Chemistry. How are you all doing? In the previous class we discussed about the chemical kinetics part 1 where we come across with the order, we come across with the rate, average rate and differential rate and factors affecting the rate of a reaction. You know chemical kinetics is all about the study of chemical reactions, right? So in session 2, it is a part 2, we are going to discuss about the order and the molecularity and different orders and their mathematical approach, very important for NEET examination, integrated rate expressions, for zero order, for first order, and also will eventually we are going to discuss about Arrhenius theory. So that is the agenda for today's class. Hi Prabhat Patel, Roshan Taker. So what is that? Okay, anyways, you are saying something? Okay, well, please like this session and share with your friends and subscribe to Infinity NEET channel. And in this, I would be very happy the students who are regularly attending the class. I request you guys please subscribe to this channel so that these sessions are going to be updated and the thumbnails are going to be seen so that you will be getting a proper NEET level coaching with your NEET YouTube channel, right? It is going to be very important chapter and you're going to get a question directly from chemical kinetics. So 4 marks will be in your pocket at the end of the session, right? Prabhat Patel, you please give me thumbs up, and all the students who are online, please like the session. Please like the session. When you click the like button, the session number is going to be increased. That can be visualized me. Session josh bhi bad jata. Okay, we are going to just introduce you Atreya program. It is the NEET repeaters program and it is the most powerful repeaters program which includes P square CB program. So what is this P square CB? You are curious about this. So when you see this 2025 NEET examination, physics paper was very tough. Not only for you, it is for all the students who are preparing for your NEET. So सबको physics paper एक slap दिया. Yes, definitely we want to take this physics paper and the difficulty level is on us. So this Atreya program is designed in such a way that after this physics is going to be no more difficulty and you can do as easy as you are in physics and chemistry and biology with the same difficulty level. Yes, definitely believe in us, and I want to just show you the program, India's most powerful NEET repeaters program, Atreya. We are going to change your state from I didn't do to I will do it, and that is all about this Atreya and the particulars of this course. And the batch is started 23rd May. Long ago. You don't worry, every week a new batch is going to be introduced where you can see this new. If you enroll, you are going to be entering into the new batch, so no worries, no backlogs, and please click the link that is available in the description box so that you can do the awesome thing with an Atreya program. And you're going to see Monday to Saturday programs and every day 3 classes per day. The program is designed in such a way that there is a less pressure on you, but more efficient work is going to be taken out. And you can say each session is going to be 90 minutes, 1 hour 30 minutes. In that 3 sessions, in that 2 concept session hoga and 1 practice session hoga. And 3 classes per day, 2 concept classes and 1 practice session. And also you can see classes per week, Monday to Saturday. Sunday ko aap chutti le sakte. And also you can have an assessment on Sunday and you can have a test on Sunday, you can have a PYQ revision on Sunday, and you will be having 18 classes per week, and in that double practice class for physics, that is very important. Simply we are not in delivering the lectures, we will make you to sit and stand, practice the questions along with an expert faculty. That's what it is mentioned here. Bacho 465 classes in the entire course beta, and in that 240 DPPs will be there. So these DPPs will have a questions based on completely pure NEET based, and it is very important And when you do these DPPs, now what will happen? You will be having an habituated to see the various models of questions. So in the real-time NEET examination, when you see a question in the real NEET examination, you will be expecting, yes, a question mein kahi dekha, and you remember the answer as well, and you know the method to answer these questions. And dedicated practice sessions are 120 practice sessions are going to be dedicated here, bacho. And after class, you don't have to worry to make a notes. Automatically the session notes will be given in the PDF form at the end of the session, bacho. And Atreya, it is the India's most powerful NEET repeaters program, mind it. And a very important thing is, for a practice session, you will be having a batch size of just 20 to 25. What is this? When you sit in a practice session, in India, nobody is going to give any online platform. Here, only 20 to 25 students will be sitting along with expert faculty, so that you will be having a direct interaction and customized doubt resolutions from the expert faculty, because you are just 1 in 20-25 students. Hi, Radhe Raj, how are you? How are you doing? And also the total NEET examination will be covered 11th and 12th standard come. Okay, so this is about the what we say Atreya program, and I have one more promotion about score here. So Sri Chaitanya Academy is in a search of just finding the bright minds across India. Therefore, we provide score examination. India's brightest begin with journey with a score. India's largest scholarship examination. Why it is called as the largest scholarship examination? Those students who are from grade 3 to grade 11 can write this examination. एक question paper के नहीं है. So segment wise question paper will be given. Okay, if you are studying any college, any institute, or you may be a student of Sri Chaitanya, may not be a student of Sri Chaitanya, you will be writing, you are eligible to write. Why not? Description box में link दिया, आप एक बार click करके form भर दो. You will be having various insights. The examination is of 2 phases. One examination September 28th का, और एक examination October 12th का. So the examination happened on September 28th. The registrations will be closed by September 27th. For the examination happening in October 12, the registration closes by October 11. And what happened, you know, so you can sit at home and you can write. It can be online as well as offline. You can go to a nearby any Sri Chaitanya Academy and you can write the examination. And this insights, you can see awesome insights. You can see, that's the reason why I say it is India's largest scholarship examination. Why? Because 2.5 crore of cash rewards are going to be given to you guys, and 350 crore of scholarships worth is given, and it may be in the form of scholarships, it may be in the form of anything. And you will be having exciting gadgets like laptops and tablets will be given to you, depending upon your score and privileged students. And also up to 100% scholarship if you opt for any course that you want to join in Sri Chaitanya Academy. And also, surprisingly, we will take you to NASA. NASA trips are also limited, for limited number of students will be given. Are you excited to go and visit NASA in United States of America? Yes, that will be on us. Just you simply fill the form and just attend the examination. Those who deserved, we will be taking care of them, right? So please like this session. Those who are online, please like this session. Okay, and also I want to take you, only one slide is there before we start the class. Agree? Okay, now India's NEET test series for Sri Chaitanya Academy by Infinity Lane. Here you are going to see here the ultimate key to NEET success. मैं क्या बोलना चाहता हूँ आपको? Whatever examination you are preparing, it is required to know how you are doing and what is your strength areas and what is your weak areas, where is your improvement areas. To know this, you need a test series. If you check with your any toppers or any winners of NEET 2024, 23, 25, you ask them, they say However you prepare, you have to attend for a test. So the test series is very important. So the most powerful test series, NEET test series, is given by Infinity Learn by Sri Chaitanya Academy. Here it is different segments. ग्रेड 11th के लिए एक टेस्ट सीरीज अलग है, 12th के लिए अलग है, एंड नीट रिपीटर बैच के लिए, ड्रॉपर के लिए अलग पैकेज है. And Violet link is available in the description box and the pinned messages. You just click it and you will identify the courses and the features on it. Very important, you can purchase this and don't forget to apply YouTube 30 off. YouTube 30 off. If you apply this coupon code, you will be getting 30% slash on the price. It is very important, bacho, and which contain this test series is going to be based on latest NTA examination pattern. So it is on upgraded version, and also this test series is going to simulate the real-time test taking experience, so that you feel as if you are in a real-time examination. And also it is created by expert faculties from Sri Chaitanya Academy by Infinity Learn. Violet, description box link is available, and you click it and you just don't forget to apply this YouTube 30 of coupon code, so ताकि आपको 30% discount मिलेगा. बच्चों, Raj and Prabhat Patel, so my promotion is over, and shall we start the class Chemical Kinetics part 2 now? Yeah, moving ahead, chemical kinetics, the rate law. Everybody give me thumbs up and fire emojis so that we can start the class. Right? Okay, what is a rate law? The speed of a chemical reaction can be explained on the basis of rate law. We have the rate of a reaction, let's say A moles of A react with B moles of B can give rise the product. According to law of mass action, rate is directly given to A moles of A, B moles of B, and this is according to rate law, according to law of mass action. But experimentally, the rate law expression is given by rate of a reaction is directly proportional to A to the power X and B to the power Y. There I have written A and B, small a, small b, here it is given X and Y. What makes this? X may be equal to A or may not be equal to A, and Y may be equal to B or may not be equal to B. So you can say rate of a reaction is experimentally find that K, A to power X and B power Y. And in that you can say the way the exponents X, Y may or may not be equal to the stoichiometric numbers, here it is given A and B, this is experimentally identified, and this is called as a rate law expression. And also you can see the rate law and the rate expression, rate constant, you can say, we can write this A, rate is equal to minus dr by dt is equal to K, A to the power X and B to the power Y. And X is termed to be order with respect to A, Y is termed to be order with respect to B. And this forms of equation is known as rate law expression or differential rate expression, and K is called as specific rate constant, or simply you can say rate constant. The magnitude of the rate constant can tell you how speed the reaction is taking place. And rate law is the expression in which the reaction rate is given in terms of the molar concentration of reactant. With each term we raised some power. What is that power? It may or may not be equal to the stoichiometric number, and that X number and Y number is only obtained by using experimental identification. That is called rate law. And rate constant for a given general reaction, I would like to say here, A moles of A plus B moles of B gives rise to C moles of C and D moles of D. And K is known as rate constant. You can write this as A is equal to 1 mole per liter and B is equal to 1 mole per liter, then rate is equal to K. So K is defined as the speed of a reaction observed when the each reactant is taken a unit molar concentration, that is what is called as a specific rate constant, or simply you can say it is a rate constant. And rate of the reaction is equal to K, as I mentioned, right? So dear children, this is a live interactive session. In this live interactive session, you can talk to me and I can talk to you. Use the chat box generously for academic communication, and please ask any doubt that you have in the class. And if you want to have this kind of sessions, you need to go to a coaching center, have to pay a lot of money. But here in the YouTube, you can simply attend at home for the free of cost, and make use of this and get advantage of this, so that what I expect nothing from you except please like the session and share with your friends. इन लोगों को भी फायदा होना चाहिए, and subscribe to Infinity Learn NEET YouTube channel. So moving ahead, here the value of rate constant is a definite, it has a fixed for a given reaction. For every reaction you won't have the rate constant same. So for a given reaction, its rate constant is a constant as long as the temperature is constant. So temperature can change its rate constant value, and rate constant is independent on concentration. If you take 1 molar, 2 molar, 3 molar, कुछ फर्क नहीं पड़ता. But rate constant only depend on temperature, my dear students. And also order of a reaction. Any doubt, bachcho? Any doubt? And in the NEET examination, you will be asking which of the following is true as far as the rate constant is concerned. So in the physical chemistry, you will be having a questions based on the theory oriented also. That's the reason why you have to learn the concepts on a granular level and in pinpoint level. So you should have that analysis. That's the reason why I strongly recommend learn properly. So don't run behind the numericals. Numericals हम कर सकते हैं, logic से हिसाब से काट सकते हैं ना. And you can say the sum of the, what is the order of a reaction? The sum of the powers of the terms used in the rate law expression is called as order of a reaction. And this order can be anything. You can see. So in a general reaction, A moles of A plus B moles of B, reactant के हिसाब से, okay, product जो भी हो सकता है. So chemical kinetics always focus on the reactant side but not on the product side. Explain the presence of catalyst at the rate constant, please sir. Definitely Prakash, at the end of the session we will be discussing that. Prakash, stay tuned. ठीक है बेटा? Yes, I really appreciate Prakash. Whenever you have something required, you can use the chat box, you can ask. I really appreciate it. And A moles of A plus B moles of B gives rise products. Okay. And according to rate law expression, K is equal to A power X dot B power Y. So something is taken in A. What is that? Active mass of A. Something is taken in B in a square bracket, that is called active mass of B. So the sum of X plus Y is equal to your order of a reaction. समझ में आ रहा है क्या बेटा? And you can say here X is the order with respect to A, Y is the order with respect to B, while X plus Y is going to be the overall order of a reaction. आपका जो X and Y, it is experimentally determined, and by looking at the balanced chemical reaction, you can never and never write the rate law. And by looking at the balanced equation, you cannot say the order of a reaction. थोड़ा experiment करके बताना. So experiment करने के ये जो data आता है ना, data देख के बता सकते हैं. Are you getting or not? So many things. Stay tuned. Now, moving ahead, order. So, order of a reaction can be either 0, 1, 2, 3. Sometimes it can be fractional, sometimes it can be negative as well. Depending on the order of a reaction, reactions are termed as 0 order, first order, second order, like that. Most of the reactions are first or second or zero order, right? And also a zero order reaction means the rate of reaction is independent on the, so rate is equal to K, let us say A gives rise to the product. I would say A to the power 0. So ताकि आपको पता चलेगा rate is equal to K. So for zero order जो rate का unit है, rate constant का unit है, दोनों बराबर होता है, प्रकाश. And you can have, how do I memorize this? Don't memorize anything. If you start memorizing na, there is no guarantee that you are going to reproduce the same thing in the examination. That's the reason why you just learn the logic. So logic के हिसाब से आपको बोलना चाहता हूँ जो zero order है ना, every photochemical reactions are going to be zero order reactions. So order of reaction cannot be predicted by merely looking at the balanced equation. This is khatarnak. This is very important. You can't say the order of reaction by simply looking at the balanced chemical reaction. And also theoretically, but must be determined, it has to be experimentally determined. It has to be experimentally determined, mind it. Okay. And order of reaction examples, observed rate loss for some reactions. I am telling you, these are the some examples I want to give you. Here 3NO gives us N2O plus NO2. So experimentally it is given KNO2 square, order is going to be 2, but it is given 3. And I am telling you this is different and this is different. This is written by using simply balancing the reaction. This is determined balancing by doing experiment. So second order with respect to NO, the overall order is going to be second, right? And also you can say 2NO2 plus F2 gives rise to NO2 F. When you say 2 and 1 here, now rate is going KNO2 F2, and it is going to be first order with respect to NO2, first order with respect to F2. The overall order is going to be 1 plus 1 is going to be second order overall. Are you getting or not? So do we have to memorize this equation? अरे मैं क्या बोलना चाहता हूँ, सिर्फ examples आपको पेश कर रहा हूँ. So example देके you can understand, yes, it is the order. And I am not insisting you to just memorize this, and this is the misconcept you guys have. Memorizing everything gives a wrong picture. And आगे बढ़ना, order. For nth order reaction, for A react gives rise to product, rate is going to be Ka to the power n. N is the order. चाहिए तो n 0 होगा, 1, 2, 3 or any fraction, or sometimes it is negative as well. And you can see, so the rate of a reaction K upon A to the power n, so that is going to be rate is equal to concentration upon time, and A is equal to concentration to the power n. I just want to say K का dimension जो है concentration to the power 1 minus n time inverse. चाहिए तो time second हो सकता, minute हो सकता, hour हो सकता. Most of the cases minutes and seconds, because chemical kinetics is only used for the moderate reactions. जो moderate reactions है इसका values minute and seconds में होगा, right बेटा? And you just see concentration का unit क्या हो सकते हैं? Concentration का unit mole liter inverse, ताकि K is equal to mole liter inverse to the power 1 minus n, and the time inverse where n is equal to order, n is equal to order of reaction. समझ में आ रहा है क्या? अगर कुछ डाउट है ना तो आपको सीधा पूछना है बेटा, जल्दी पूछो. And I just want to show you units of rate constant. Various reactions are shown like this. For a zero order reaction, apply the same thing in the expression, so that you're going to see mole liter inverse and second inverse. So बच्चों, you can see here, you can see for a zero order reaction, the rate constant का जो dimension है, rate of a reaction dimension का बराबर हो सकता, right बेटा? And for the first order reaction, you can take here mole liter inverse upon second into 1 by mole liter inverse upon 1. So that I just want to strike this. So you are going to get second inverse. You are going to get second inverse is the unit for the first order. And for the second order, जैसे आपका mole liter inverse upon second into 1 by mole liter inverse square. So on doing so, mole inverse liter second inverse is going to be the unit for this second order. Like that, for any nth order, you can directly calculate by using this formula. So बच्चों नीट एग्जामिनेशन का फिलहाल 2 बार ये यूनिट का हिसाब से क्वेश्चन पूछा गया. You understand बच्चों, it's very important, very very important. Now for a reaction A plus B gives rise to product, it's a question. Okay, and the rate law is given by rate is equal to K A power 1 by 2 and B square, and your what is the overall order of a reaction. I want to know your answer by chat box. Everybody, you give the answer in the chat box so that we can understand how you are doing. Sorry, excuse me. Overall order is going to be A का हिसाब से 1 by 2 है ना, B का हिसाब से 2 है ना, it is going to be 2.5. That's very good. Prakash, you kept quiet. Keep talking, right? Well, very good. So those who are online, please like the session. Please like the session. Okay, Prabhat, Betu is there in today's class. And I really appreciate those students who are regularly coming to the class, and you please continue. By any chance, if you are absent for any doubt, history with Khairul Wala. Good. Okay, anyways, by any chance, if you miss to give an answer, you please take this recording and watch the recording, and while doing recording, if you still have any doubts, you just mention in the comments, so that I am going to watch these comments and give you. Okay, now look at this. For a reaction A plus B gives rise to the product. So this is the following data is observed. So in this following data, you can see, let me draw a table over here. So this is the experiment actually. In this experiment, and this model of questions are very important, and observe this given data and write the rate law and find the rate constant of the above reaction. Okay, let us rate constant बाद में कर सकते हैं. पहले ये ऐसा क्वेश्चंस देंगे तो you are taking A plus B gives rise to product. Okay, zero order Prakash. Okay, sir, आप बहुत अच्छा पढ़ा था. Thank you very much, and thank you. And you can see here, when concentration of A and B are allowed to react, this is experiment number 1 and experiment number 2. So in the experiment 1, 0.1 liya, and experiment 2, concentration of B is constant and concentration of A is a double ले लिया. So concentration double लिया तो rate double बन गया. So with respect to so A से depend कर रहा. Okay, so that we can say with respect to A, rate is equal to K A to the power and B to the power. So the concentration is doubled, the rate is doubled with respect to A. We are not changing the concentration of B. So B का influence कुछ नहीं है. So that I want to say A to the power 1. And talking about B, when you talk about experiment 1 to experiment 3, A का concentration constant लिया and B का concentration double बढ़ गया, but rate of a reaction 0.05 है. So that if B concentration is doubled, the rate is not changed. So that it is not dependent. So with respect to B, the order of a reaction is going to be 0 and overall order is going to be is equal to 1 plus 0 is equal to 1. How simple the questions can be answered in the NEET examination, bachcho. How simple. Samjhe? How simple. Any doubt? Prakash, correct yourself. Kairulvara, corrected, fine. And now, what is again another terminology is coming, that is about the molecularity. Okay, thank you for this very difficult chapter, but you method is very best. Thank you very much. Again, thank you. And you please correct yourself. Yeah, but the unit is not second inverse, na. रेट कांस्टेंट का नहीं, ये रेट का है. रेट का यूनिट हमेशा मोल लीटर इनवर्स सेकंड इनवर्स. ओके, व्हाई इट इज फर्स्ट ऑर्डर. सो इफ द concentration is doubled, speed of a reaction is doubled, rate of a reaction is doubled. If concentration is doubled, rate is not changing, it's 0 order. If concentration is doubled, rate is doubled, first order. If concentration is doubled, rate becomes 4 times second order. Okay, got it? So, you feel this is useful information, Prakash? Useful information, Prakash? Very good, nice. So, moving ahead here, order is completed. Let us talk about the molecularity. During a chemical reaction, the reacting molecules making a collision, then only reactant is converting into product. So, how many reacting species are making a collision in a single step is called as a molecularity. Molecularity of a reaction is simply the number of reacting species. Reacting species means it could be molecules or ions or atoms, whatsoever it may be, are making a collision in a single step. जो single step का reaction आता है ना, technically elementary reaction बोलते हैं. So in an elementary reaction, and that is called as a molecularity. The molecularity is the number of reacting species that making a collision, that's it. Okay, so let us consider here reaction and the molecularity. NH4NO2 सिर्फ एक ही molecule involve कर रहे हैं ना ये reaction के हिसाब से, it is called as molecularity 1, unimolecular. Let us do one thing. 2HI gives rise H2 plus I2. So 2 molecules are involved. So this is called as bimolecular reaction. And you can say it is also a bimolecular, and here. So 2 here and 1 here. Termolecular or trimolecular reaction. Molecularity cannot be greater than 0. It cannot be 0 and greater than 3. Why? Because logically 3 molecules cannot come, more than 3 molecules cannot come and make a collision. So if molecularity is expected to be more than 3, you can split the reaction into simple steps. That may be a complex reaction. So that's all about the molecularity. Why the reactions having molecularity greater than 3 is rare. That's what I want to say. It is impossible. Logically, it is not possible, since the chances of collision is very less. Okay, that's the reason why whenever it is generally coming to be greater than 3, we have to assume that it is a complex reaction and we have to take the simple parts, understand? And molecularity in the case of complex reaction, you have to say the complex reaction is taken into the simplest possible way. Yeah. सर ये क्वेश्चन पेपर में क्या डिफरेंस बिटवीन द रिएक्शन मॉलिक्यूल बोर्ड्स में दे सकते हैं, बोर्ड्स में दे सकते हैं, ओके, बट नॉट इन द नीट एग्जामिनेशन. बट डिफरेंस का हिसाब से ही एक लॉजिक स्टेटमेंट निकाल के आपको बता सकते हैं. ठीक है, right? History. Okay, thank you. Let us move ahead with the differences in the molecularity and order of a reaction. You know about the order, you know about the molecularity, but you see the difference between the order and the molecularity, na? Yes, you will understand. Here, what is the order? What is the molecularity? Molecularity is the number of reacting species that are making a collision in elementary reaction. That is called molecularity. Then what is order? Order is the sum of the powers that are shown in the rate law expression, that is what is called as the order. Right? Prakash, Kairulvara. Now let us see in more details about this. And the molecularity of reaction cannot be zero. So collisions are taking place. If a molecularity is zero, collision is not taking place. Example of molecularity may diya ho na. Example of molecularity, here you can see these are all the examples. No? You understand? Clear? Understand? That's good. And this is about the molecularity and the order. Now molecularity of reaction cannot be zero and order can be zero, sometimes fractional also. Yes. And also you see, it is a theoretical concept. The table is ulta pulta ho gaya. It is a theoretical concept and the order is going to be explained only experimentally. Only experimentally. And also you can see it is always a whole number. It cannot be fractional and order can be fractional. Order can be fractional. Thank you very much. Thank you. And you can see overall molecularity of the complex reaction cannot be greater than 3. Okay. And if it is greater than 3, you have to take these individual steps. Individual step का molecularity होगा, overall reaction का molecularity नहीं होगा. But if you take order of a reaction is given for the overall reaction, हर step को reaction नहीं दे सकता. ठीक है? Thank you very much. And you can see the reaction 2O3 gives rise 3O2. The process given a hypothetical mechanism like this. Based on that, the rate law is given as super question. How many of you can do it? If you can do, please mention the answer in the chat box. Otherwise, I will do it. I will take a chance. Right? Yeah. Take a minute. Make it fast, quick. Make it fast, quick. Well. A minute or half minute or 1.5 minutes. Mind it. Yeah. So this is a difficult question. Okay, let it be difficult question. I'll make it easy. मैं हूँ ना. Yeah. You can do it. That is the belief system. Bachcho. That is the belief system. Those who are online, please click the button, like button, so that we can have the interaction between you and me. So please like the button, and you can see always order in a multiple step reaction, always the order is given for the slow reactions or rate determining reactions. Hi Hamza, how are you? Hamza, how are you? Ek bar, yes. Now always rate is depends on slow reaction. So that is called slow reactions are rate determining reaction, RDS. For a complex reaction, some reactions are slow, some reactions are fast. The slowest possible reaction is said to be rate determining step. Okay? And only kinetics are studied there only. So according to that, rate is equal to K O3 and O. Do you know one thing? O is an intermediate. Intermediate should not be present in rate law. It should not be present in rate law. So I don't want to see this over here. So let us take it out. So how to take it out? Take a pencil eraser and remove it. So that O I just want to take based on this reversible reaction. For reversible reaction जो है ना, इसका क्या होगा? It is going to have the Kc is equal to O2 and dot O upon O3. Are you getting or not? Yes. क्या फर्स्ट लाइन में स्लो रिएक्शंस आर सेड टू बी रेट डिटरमाइनिंग स्टेप. समझे बेटा? RDX का मतलब क्या? रेट डिटरमाइनिंग स्टेप. सो मैं O पकड़ना चाहता हूं. सो वो आएगा आपका, वो आएगा आपका it is going to be, O is going to be Kc dot O3 upon O2. है ना? नीचे intermediate should not be present in the rate law. ठीक है? Intermediate should के आगे सर, हाँ, ये निकालने के लिए मैं कुछ काम कर रहा हूँ बेटा. ये जो वो ना नेसेंट ऑक्सीजन है, इसका एक्सप्रेशन कैसे बन गया? कैसे का हिसाब से. सो ताकि आपका रेट इज इक्वल टू के O3 एंड इसका Kc, O का जगह Kc एंड O3 अपॉन O2. ठीक है? सो आई जस्ट वांट टू राइट दिस एज रेट इज इक्वल टू K dot Kc and O3 square upon O2. समझ में आ रही क्या? राइट. K is rate constant, Kc is equilibrium constant. दोनों मिलके और एक नया constant बनेगा. That is given as rate is equal to K dash O3 square O2 power minus 1. So you can check it. Option 1 is the correct answer. Hope you understood. अगर कुछ डाउट है ना तो आप पूछना. And this is the model of question you are going to expect mostly in NEET examination. You will study in the textbooks, you study from the materials, but examination में questions अलग आता है. So अलग पकड़ने के लिए ये जो टॉपिक्स है ना, ये जो ट्रिक्स दिया, आप सीधा ये सीखना है. अगर कुछ डाउट है ना तो चार्ट बॉक्स में आप बोलना. Make it fast, make it fast. Prakash. Prakash. Yes. So be interactive बच्चों, be interactive. So आगे बढ़ना है बेटा. Now, which of the following statement is incorrect? Okay, we'll discuss about integrated rate expressions. Integrated rate expressions. When the concentration is taken and with respect to time, the concentration of the reactant is decreasing. The change in the concentration at that instant is different. The change in the concentration at this instant is different. The change in concentration at this instant is different. So I want to take all changes from here to here. and I have to integrate the change in the constant rate from T1 time to T2 time, or C1 concentration to C2 concentration. So that is what is called as integrated rate expressions. Integrated rate expressions can give you a lot of insight about the learning process, and definitely if you have a question based on the chemical kinetics, you will be having a question based on Arrhenius equation or based on the integrated rate expressions. Okay, and you can say zero order reaction is a reaction where the rate of a reaction is independent on the concentration of the reactants. So let us say reactant gives rise a product. Zero order क्या बोलना चाहता हूँ, rate is equal to minus dr by dt is equal to k r to the power 0. 0 means a zero order reaction. This is a zero order reaction, है ना? And I want to say any quantity raised to the power is 0 is unity. Therefore, rate is equal to minus dr by dt is equal to k into 1. So, dr is equal to minus k dt. Dr is equal to minus k dt. So, we will integrate this from concentration R naught to concentration RT, and we are going to take the time T naught to and time t. So, on integrating, so integral both sides between the proper limits R naught to R and 0 to t. Okay. So, you are going to get R minus R naught is equal to kT. R naught is the concentration at initial concentration, and R is the concentration at time t. So that you are going to get, or this is written as R naught minus R is equal to kT. Just sign is changed, and k is equal to R naught minus R by t, and it is going to be k is equal to R naught minus R by t. This is called integrated rate expression for zero order reaction. It is for zero order reaction, and it is very important. By using this, you can write the graph. What is that graph, you can say? So, this is the graph, concentration of the reactant versus concentration of a time. You are going to get a straight line with a negative slope where the intercept is given on y-axis. The intercept indicates that initial concentration, and you are going to get a slope, and the slope is going to give you the rate constant. And based on this, it is a snapshot of the NCERT textbook. We are connected to the NCERT. NCERT is everything. And if the slope is given, you can calculate directly the rate constant for zero order reaction. Understand or not? Any doubt, Prakash? Those who are online, please like the session. Now we'll go into the details of this. Let us talk about the first order reaction. What is first order reaction? The rate of a reaction is directly proportional to the concentration of reactants to the power 1. And this is called as a first order reaction. You can take an example of decomposition of hydrogen peroxide. And you see, rate gives rise to the product. And you can say, rate is equal to minus dr by dt is equal to kr to the power 1. Because it is a first order reaction. And or you can say dr by r is equal to minus k dt. Now we will integrate this equation. We are integrating this. Integrating on the both sides, you are going to get initial concentration R naught से R तक integrate कर रहा हूँ, times 0 to t तक कर रहा हूँ. So, on doing so, you are going to get a logarithm expression. So, ln r minus ln r naught is equal to minus k dt, and ln r naught minus ln r is equal to kt, or kt is equal to ln r naught upon r, and k is equal to 1 by t ln r naught upon r. So, this is what you can say the integrated rate expression for the first order reaction. It is given as a k is equal to 2.303 by t. log R naught by R. Hi Bahi, how are you? And you are going to use this expression for more than 100 times when you prepare for a kinetics chapter. And this kinetics chapter, Arrhenius equation is one and this equation is another. They are the king makers. Definitely you are going to expect a question based on this. So don't forget this, and let us take from here to here. You are going to get a graph. So that is ln R naught upon R versus 1 by T. You are going to get a graph here. You can say K is equal to 2.303 by T log to the base 10 of R naught by R. R is the initial concentration and T is the time and R is the concentration at that time. And you can say log R naught by R is equal to KT by 2.303. Where these 2.303 has come? Because ln x is equal to 2.303 log to the base 10 of x. So based on that, natural logarithm is converted into logarithm to the base 10. Mahi. So let's say this expression can give you a graph. This expression can give you a graph. That is going to be log R naught by R, log R naught by R, and time, okay, log R naught by R is directly proportional to time, so that it is going to be a straight line. Understanding mathematics is very important, however you are a biology student. And a straight line with a positive slope, slope kitna de sakte hain? This is going to be, you can write this as rather log R naught upon R is equal to K by 2.303 into T. It is equal to Y is equal to mx plus C. So it is going to be the slope K by 2.303. If slope is given, you can directly calculate the rate constant. Understand or not? You can do it now? Yes, perfectly you can do it. And you can say, okay, this will do. Yeah, half-life of a reaction. Very good point. What is the meaning of half-life? Half-life of a reaction means the time required to consume half of its initial concentration is called half-life. So for T half for a zero order reaction, let's see here, for a zero order reaction rate constant is given as K R naught by R by T. So at T becomes T half, R becomes R naught by 2. So R becomes R naught by 2. So R naught by 2. So you are going to see T half is equal to R naught by T 2K. We want to say T half for the zero order is directly proportional to initial concentration. So if you say T half and initial concentration, it is going to get a straight line. Okay? Or otherwise in the either ways you can say, initial concentration at T half, it is going to get a straight line. Any doubt, bachcho? Please ask Prakash, Kairalwara, Mahi, Hamza, waiting for your questions here. Once your questions are done, ये T half first order को कैसे करना? Yes, you can do this T half for the first order as well. Thank you very much. Mahi, एक बार like button मारो. So for the first order reaction, it's clear that the first order zero order reaction is directly proportional to the initial concentration for zero order is equal to A naught by 2K. So you said R naught by 2K. So depend upon the situation, depending upon the book, different terminologies can be used, right? You don't fix to one parameter, rather you fix to multiple parameters. So let it be X or Y or Z, no problem. Now let's talk about T half for the first order reaction. T half for the first order reaction. So for a first order reaction, we know that K is equal to 2.303 by T log R naught by R. R naught is the initial concentration beta and R is the concentration at the time T. You know, one at the time T half, R become R naught by 2. R become R naught by 2, है ना? So that उसमें डालो. So that your the above equation becomes like, you know, K is equal to 2.303 by T half log R naught by R by 2. R naught by 2, R naught by 2. So the T half is equal to 2.303 by log 2. You know, log 2 value is going to be 0.3020. And you can say T half is going to be 0.693 by K. 0.693 by K. I want to say T half is independent on the concentration of the initial concentration of the reactant. Initial concentration of the reactant and the T half if we take for the first order reaction, it is independent. It is independent. Any doubt? That's very important. T half is given, you can calculate K. K is given, you can calculate T half. That is quite useful expression. T half, simply say that 0.693 by K. K is the rate constant. K is the rate constant. ठीक है? And thus the first order reaction half-life period is constant. It is independent on the initial concentration of the reactant species. So I just want to give you a beautiful trick. Let us say T half for the reaction is going to be 5 minutes. 5 minutes, right? Initially 100 moles are taken or 100 grams of the substance is taken. उसमें आधा कंज्यूम करने के लिए सो 50 ग्राम्स बचा हुआ 50 ग्राम्स खत्म किया. सो आपको 5 मिनट्स लगेगा. राइट नाउ यू हैव टू टेक दिस 50 ग्राम्स एज इनिशियल. 50 25 होने के लिए यू आर गोइंग टू गेट और एक 5 मिनट्स है बेटा. ये 25 12.5 होने के लिए और एक 5 मिनट्स होगा. ये 6.25 होने के लिए और एक 5 मिनट्स होगा. Now you can see the time that you are using from here to here, it is 5 minutes. From here to here, it is going to be 10 minutes. From here to here, 15 minutes. From here to here, 20 minutes. You see this logic. Bacho, you see this logic and you will understand how the kinetics of the first order is seen. How much amount is left after 20 minutes? And you tell me how much time is required to make it zero. How much time is required to make it zero? I have a question. How much time is required to make it zero? To make it zero, you require infinite amount of the time. First order reaction never complete. Okay, anyways, the time is बहुत हो चुका. We will be conducting one more session for the chemical kinetics bachcho. In this, we are going to talk about the Arrhenius expression and the collision theory. Prakash, there we will be discussing about the catalyst effect activity and everything. Hope you like this session. We are done from our side in today's class. Hope you like this session. Yeah. Please like this session and share with your friends and subscribe to Infinity Learn NEET YouTube channel. Okay. Thank you. We are done from my side. Thank you very much. Signing off, Suresh, Faculty of Chemistry from Infinity Learn. Bye bye. We'll see you again with more stuff in the next upcoming sessions. Thank you.